This Python coding tutorial video where we're going to recreate Minecraft, or a simplified version of Minecraft. So let me show you the code working. We're just going to do a terrain of 50 by 50 voxels or cubes, and we're using the Ursina Engine made by Amland. So here we can see the terrain being generated. So that's what I'm going to show you how to do. We can hear some footsteps as well. We've got a 3D model. Actually, we've got two 3D models. We've got our diamond axe, and we've got our mob, our creeper, who's actually looking at us. Creepy. Creepy. And we've got a nice small terrain, although this is a lot larger, I think, already than the very simple, like basic Python Minecraft, given an example by the Ursina Engine, or you can find it on the Ursina Engine website. Right, sorry. So, standing up here, we've got the high ground, and now we can just have an overview, if you like, of what we're doing. So, although we've got a small terrain, or smallish terrain here, we can generate, with this system, a much larger one, with a nice simple code. So that's what I'm going to show you how to do. How to get colours and things. We can switch building mode on, and we can do some building. We can also mine. I haven't got an animation yet for the axe. We can select different blocks and place those as we wish. I want a grass one as well. There we go. Lovely. So I'm probably not going to show you the building, in the first video. I'm just going to concentrate on getting your character being able to move around and generating the terrain. That's probably the most complicated thing that we need to look at before looking at the other details. And then in any future videos, if you want them, we can look at doing proper mining and maybe looking at mobs and generating trees and other things like that. Right, let's get going. Press escape and we're out. Okay, so the first thing we need to do is to get you started. Get yourself a fresh Python text file ready. I'm going to go right from scratch. Indeed, I'm going to show you just how to install Ursina. Let's just make this a little bit bigger. So if you open up Terminal, or if you're on a Windows machine or Linux, the equivalent, maybe PowerShell, something like that, and then you're going to use the pip installer, pip install Ursina. That's the first thing, and then press return or enter, and that will install. If you have some problems, maybe we're using pip3, so same thing, Ursina, and we're going to install Numpy for some maths things that we need, and we're going to install Perlin, and it's hyphen noise, Perlin Noise, and we're going to use Perlin Noise to generate the hills and the landscape, the terrain. So that's really important for this tutorial. So those things, I'm not installing them because I've already got them installed. So you wouldn't just do that, you would press enter, remember, to get them going. If you have any problems with that, I'll try and leave some links to help you out. For example, if you go to the Ursina Engine or ursinaengine.org website, so the Ursina Engine is the piece of genius written by, where's his name? Amland. Fantastic. Do help him out on Patreon. Is this Patreon? Yeah, Patreon. If you want to help him out. He makes all of this possible. On his website, or the Ursina website, there's loads of helpful things for getting you started. There we go. And troubleshooting if things go wrong. And I'll give you equivalent link to get going with Perlin Noise and the Numpy. I'm sure you'll be fine with those. Right, so first thing we want to do is from Ursina, now that we've installed it, import everything. So you're going to use that star, and then let's just get a cube and a window kind of working. So if you've used Python before, you're going to be amazed at how little we need to use. How little we need to code before we can get things usefully on screen. So we're just going to say app, we'll call it app equals a new Ursina object. Window, what should we do with the window? We'll just change the color, equals, if you want to do red, green and blue, I love using red, green and blue. So I could just, write cyan or blue or something like that, I like selecting exactly how much red, how much green, how much blue, and you can use an alpha channel here as well. You just put an A for alpha. So we can go up to 255. So I don't want any red. Or just for fun, shall I make a pink? Yeah, I'll make a pink background. So loads of red, no green, and loads of blue. And I don't want to see the exit button. So I'll set that to false, and we want our app to run. So let's just do that for now. Let's just see if I've got that right. So I need to save my Python file, PyCraft tutorial 1. Let's run this. Oh, yeah, that's very pink. Oh, I've got my exit button. I shouldn't be able to see that. Let's see if it's working. Yep, it is working. Let's just go to my already prepared code. App Ursina window color, window exit button visible. Aha, that's what I got wrong. So exit button visible is false, and now I won't be able to see that. We're gonna have to change this pink. That was a little painful. Let's just mute it down a little bit with a nice tropical kind of greeny, bluey turquoise. And we want a cube. So how do you make models and things in Ursina? Let's just call him Jeff. Is going to be our entity. So Ursina uses entities, and that's how to create an entity. It's that simple. We've now got an entity called Jeff in our world. We probably won't be able to see him because he doesn't have a model. So if you wanted a cube, you can literally just write model equals, and then in as like a string cube. There we go. Save and run. Yep, we've got our cube. It looks like a square, I guess, because we're looking at it straight on. My background's a little too green, isn't it? I just noticed the exit button was still working. I couldn't see it. I need to be able to escape, actually. So let's just write a little function called input, and it's going to take a key, and we're just going to say if key is Q or escape, then escape. It just reminded me of, what was that? What film was that from? Like Dory, Finding Dory, or Finding Nemo. If key equals Q or escape, then we're just going to quit. I think you could also use exit. I'll use both of them. Why not? Oh, it's kind of going a different color. I'll just use quit. Let's just see if that now works. And we'll get our cube. Let's give our cube a color. Color equals color dot. I'll say pink. Oh yes, and I just needed to increase the amount of blue. Save the file, run, and we've got a pink cube, and our sky is a little nicer coloured. We've got 60 frames per second. If I press Q, yes, now it quits. That's nice. Okay, how do we get our cube rotating? Well, notice that the Ursina has an inbuilt input function and for dealing with input, which is really easy. It's also got, like in Unity, an inbuilt update function. And I can just ask Jeff to rotate. So I can say his rotation underscore y, that's the Ursina convention for getting, say, the x rotation, the y rotation, axis rotation, sorry. And I can just say plus equals, let's just say 0.1, and then on every update cycle, Jeff should be rotating. Now, the one bug that might happen is that update might not know what Jeff is, so I might have to add him as a global variable. Let's just see. Yeah. Oh no, it is actually working. There is some rotation happening. Let's add some more rotation and maybe a texture. So let's add rotation to the x-axis as well, and let's just increase that by 7, that one by 3, and we need a texture so we can actually see things properly. So first I need to go and get a texture and put it in in the same folder as where you've saved your Python code. So that's the wrong thing. That's what I wanted to look at. I want to look at my folder. So this is my folder. I've just got my Python code in there, but I've got some assets prepared. So let's go to textures, and I've made these just using GIMP and some noise. So grass 14 I'll use, or grass 12, grass 14. I'll go for grass 14. It's got like this white border, so we can see where cubes are. So let's just copy that, go into my folder, so where my code is, and as long as they're in the same folder, or if there's another folder, I'll just make one now, and I'll just call that assets, even though they're now not in the same folder. As long as this folder is in the same place as where your code is, the Ursina engine will be able to find your textures and your other assets like models and sounds. So Ursina works really nicely for things like that. Right. So now that we've got a texture ready, I'm going to say texture is, and I'll call this grass grass stroke text, because it's got like a stroke or a line around it. So this texture doesn't exist yet. I could load it in here, or I could just put the name of the file here. So I could just put, what was it called? Grass 14 PNG. I could just write that there, like this. Let's just grass 14 PNG. That will work. Let's just see if that works. Yeah, there we go. That's pretty cool. So, but that's interesting. I just clicked on the screen and it quits. Interesting. So maybe before, when I thought I hit the button, it wasn't just invisible and still working. Just anything that I was doing in terms of input quits the program. Hopefully that won't be a problem when we start doing things. Yeah, I don't know why that's happening. Anyway, right, let's continue. So I was just showing you how to load in a texture, and we want to put grass stroke text there because I want to load it. Really, you want to load your textures before you're using them, like during the game, because that might slow things down. So grass stroke text equals load texture, and now we put in the same thing, grass 14, and I think I can just leave it as grass 14. Again, Ursina will just go and find your file. I'll just put PNG just to, maybe that's faster, but there we go. Save that. Good. Now we're going to talk about the next thing. So I guess what we want to do, what if I just press a key? Yeah, if I just press any key, then it quits. This is a bit of a problem. What am I doing wrong? Let me just go and look back at my code here. I'm just going to have a look at maybe maybe, nope, I don't know what I'm doing. I don't know what's going on. Hopefully it isn't a problem. Let's just keep going. Let's just keep going. Does update need something in? Maybe it's something to do with update creating a problem. Let's have a look. There's my input. Update. No. Or maybe it's to do with Jeff. Maybe it's Jeff's fault. Global Jeff. Let's put another key. Oh, well done if you spotted my bug. I've said if I've been too English about this and not programmy. If key is Q or escape, I need to say or key is escape. There we go. Now I think I did that after I took away the button up here, so I don't know. Maybe it is still working invisible. Let's just. Okay, so now I'm tapping the screen, pressing different buttons, and it's not quitting. If I press escape, then it quits. Okay, lovely. I'm glad I cleared that up. So, Jeff, you don't have to be global, you're fine. Right, for some reason our programs can find our entities as though they were global things. Right, so now we need a first-person controller and maybe somewhere for our first-person controller to walk. So maybe instead of one cube, we'll have lots of cubes. So we don't want Jeff rotating, and we want to go and create lots of them. So a grid of Jeffs, and we're going to do that with a loop. Now you'll notice that Jeff looks unhappy here, and if we try to run, it won't run. And that's because in Python, if you've just declared or defined your function, then it's expecting something to be on the next line. So you can't just leave it empty like that. You have to write, say, pass. So if you don't want to put anything in there, pass. I don't think a comment will work either. But if you use the pass keyword, now everything's happy. So you've just basically got an empty function ready to go. But I'm going to leave that there. Right, so now we need the first person controller. No we don't, we need a ground, else we'll just be falling. So we've made a Jeff, so we need to make lots of Jeffs. So let's create a loop for I in range, and we'll go for terrain width, we'll call it. So we'll make a variable here, terrain width equals 10. We'll just go fairly small. So actually, we're not just going to make a line of 10, we want to make 10 across the x-axis and then 10 down the z-axis. So actually we want terrain width times terrain width. We're going to square that number, so it's going to be 100 blocks or cubes. Okay, so first thing we need to do is create that cube. So we'll just call it bud, for like a little buddy. It's just a little traditional thing I do for temporary entities. For some reason I call them buds. So my little buddy equals a new entity, and I want its model to be a cube, just as before. What colour should we go for? We'll go for green. Colour equals colour green, and yeah, we'll have the same texture as we had with Jeff. We'll leave Jeff there for now, or shall we not? Nope. Sorry, Jeff. Time's over. Time's up. And what else do we need to do? We need to position them. So now that we've got this entity stored in bud, we can say bud's x position. So you can just do .x, and then that will mean your entity's x position. The longer way to do it would be position underscore x. I think that's correct. Position will be a vector 3. Anyway, position x equals, what we want to do is I divided by the terrain width, and that will give us our, as it were, rows. And then bird dot z equals I modulus terrain width, and that will give us our columns. Okay, you might be a little bit confused. Don't worry. We could use, if you've done grids and things before, we could use a loop within inside of a loop. So we could nest loops. So we could do the outside loop for the x positions, and then the inside loop for the z positions. But if we just want to create things with one loop, we can just use divided by and then modulo to get our grid positions. We'll see that working in a moment, and we'll say bird dot y equals 0. Okay, let's just go and see if that's now created our 100 cubes. Yes, we've got 100 cubes, but presumably we started at 0, 0, but it looks like we've just got a line of them, and we don't know if we've actually got a grid. So that's quite exciting. Let's now generate our first person controller, which Ursina basically has done for us. So from Ursina prefabs, import first person controller. I just want to check that I've done that right. From, oh no, excuse me, just sneezed. From Ursina prefab's first person controller, import the first person controller object. So let's go and correct that. Now we want to import the first person controller, like that. Lovely. Now we can go get our first person controller. We'll create the terrain first, and before we ask the app to run, we'll say subject equals, I guess you could call this player if you wanted to, or your name, whatever you liked, equals first person controller. Then we want to move us subject equals subject x equals 5, and we'll do that as well for our z position. And if you want to set two variables to the same number, you could do it in one line like that, instead of doing it kind of like on two lines. And our y position, subject y equals, let's put us 12 in the air, and then because we've got the first person controller, gravity should be working already for us. So let's just see if that's working. Whoa. Okay, so I fell through the floor. It looks like we've successfully created a grid. And what I've forgotten to do is give our cubes a collider. Now I could give each cube its own collider, but what we really want to do is combine them all together and just give that whole model one collider, so it's a lot more efficient. You wouldn't notice the difference for a size of just 100, but if we had 10,000, like we'd have in an ordinary terrain using my system, then we'd definitely have to do it this way. So this also sets us up for creating the terrain, I guess. So we're going to call our terrain, we'll just call it terrain for now. So terrain equals new entity, and model we're going to set to none. That's how to, if you want things to be empty, in terms of the properties of an entity, an Ursina entity, then that's the syntax. And we don't want a collider yet either. And we do want to use the same texture at the end. Anyway, we'll worry about textures and things in a moment. So after we've created our terrain of 10 by 10 cubes, we then want to ask the terrain to combine all of those cubes into one model. And you do that by just saying the entity's name dot combine. Now, how does it know which entities to combine? Well, it will combine all of its child entities. So you can make entities within the scene kind of attached to what we call a parent entity. And if you have done that, it will follow that entity around if you move it, or if you want to combine it, it will combine into its parent. So first we've got to make all of our buddies bud parent equals terrain. There we go. And now that will combine. You can also auto destroy to false or true. I think it's automatically on true. So once you've combined all of these cubes, all of these models into this single model, then it will automatically destroy the child entities. But maybe, like in my terrain, you want to reuse these to create another part of the terrain, another chunk, if you like. Then you'd want to set this to false. That will come into play later on. So let's just have that as true, which is a default, so I can just leave it like that. And then I might want to set the terrain's texture. Let's just see what happens now. Let's just save the file. And, oh, the whole point of doing this was to give it a collider, wasn't it? So instead of having to set the individual colliders, we can just set one collider, which is much more efficient for the physics engine here. And we want to say use the mesh, and that's what we've just created with this combine function. The mesh is created out of all of these cubes fused or combined together. Okay, let me look down. Brilliant. So I've got my first person controller. It's working. So I'm using WSAD, which is the default keys. I can press space to jump up and down. We've got gravity working. And yep, I can fall off the edge. Now, interestingly, although we set the texture of each cube here, when we combined those cubes into the terrain entity, then we lost that texture, although we retained the color. We haven't set the color of our terrain. So what we'll do is take the texture off here, because that's doing nothing, so this is more efficient, and this nicely goes onto one line, and we could set the texture of our whole terrain equals was it grass stroke texture. There we go. And let's run again. And what's really nice is that because we've made it up of blocks, our larger texture isn't just one of these stretched over it, but it's repeated, which is really good. So we can have individual textures, individual colors. If we wanted to. I'm just noticing these are slightly out of sync. Oh! And that's because what we want to do is a Minecraft kind of thing, isn't it? We want to floor these numbers, which means make sure they're a whole number. So let's do this up here. We need to import Numpy or NumPy. So from Numpy import, actually all I want is floor. Can I just use floor now? Can I just say floor, that number, and then floor, that number, and then of course floor y as well, although that's set to 0 so that's pointless. Right, does this align them up as a proper grid? Let's have a look. Yes, it has. Now we're all squarely aligned like in Minecraft. Okay, I guess what we should do, since we're working with this mini terrain, is add some Perlin noise, so to get it nice and bumpy. So we'll make it a little larger. Now that we've got our little system, we can actually just go 100 by 100. I'll just say 32. And then, let's just see how that looks. Very good, 32 by 32. Notice we've got exactly the same frames per second. And you'll have exactly the same frames per second if you put it 200 by 200. So that's, is that 40,000? I'm not good at arithmetic. Is that 40,000, something like that, individual cubes making up a giant terrain? That's what I've tested it at so far. I haven't got larger than that. Okay. So we want some Perlin noise. So the last thing we need to import, I believe, is our Perlin noise. So from Perlin noise, by the way, you install it and it's called Perlin -noise, but when you import the module here, it's _noise, so it's a little a bit of a discrepancy. And we'll call that actually, I'll do it this way. Import Perlin noise as, no, I want to, from Perlin noise, import noise. That's what I want. Or do I want Perlin noise? What do I want? Let's go to my prepared code. I want Perlin noise like that. And then I'm just going to get this here ready. Okay, so from Perlin noise, import Perlin noise, and then we can set up, I guess, when we're doing our terrain stuff. Let's do it here. We can say noise equals Perlin noise, and then first we need how many octaves we're going to use. And let's just say 1 for now. I'll explain what those are in a moment. And then seed, just like in Minecraft, this is, so we've already got built in seeding for our terrains. Let's just choose today's date, 2021. Hello from the future, or rather from the past to the future, if you're watching in the future, from 2021. Right, what we also need to use when we're using Perlin noise, in fact, let's just, I haven't tried it without doing something, sorry, I'm ranting, aren't I? Not ranting, but whatever the word is for when you're talking nonsense. I'm just talking nonsense. I'm just going to go down to my prepared code just to remind myself of how I'm doing things. So this is where I'm using noise. And let's, in fact, let's just copy that in. And place it here. So before, when we were generating our grid of cubes or voxels, we were just saying y equals 0. So this time I'll keep the floor there to make sure it's like at exact integer values. But what we need to do is the following. We're going to say, I should say bud.x and bud.z. So to use it, to use this Perlin Noise object, so I've called it noise, and it's a Perlin Noise object with 1 octave, and its seed is 2021 as properties. So it will spit out, notice the square brackets, it's a tuple, sorry, a list, or a tuple, I've forgotten, it's one of the two. Apologies to proper Python programmers. So there's a few brackets going on. It's going to take an X and Z, or an X and Y if you like, if you think about it in 2D, position, and then it will return you a number, and that number is going to be related to where its position is, so it's not completely random. So if it was random, our terrain would just be bumpy all over the place and it wouldn't look like a terrain, but here we'll have hills and things, so that's why we're using the Perlin Noise. And I've done something wrong here. Am I missing a bracket? Yes, I am. There we go. Let's just see what this looks like. I don't think it will work because we need to make it slightly higher, but who knows? I've never tried. Yeah, so it just looks completely flat. So one thing we might need to do is multiply that value, because we might be getting a value returned between 0 and 1. So let's amplify it by a scalar we'll call amp for amplitude, which is traditionally what you do when using Perlin Noise. I'll call that amp equals, and I like to think of it, what's the maximum height that you want? Let's just try 3 meters. Let's just see what that does. Okay, so we've still got a flat. I don't know if it's completely flat, but we've got a flat looking terrain. So the other thing that we need to do to finish this off is divide each value by a frequency. So I'll call that frec for frequency. And usually the frequency will be higher than your amplitude. Save that, press play. Who's betting we still got something flat? Oh, I was going to. I just lost a bet against myself. But there we go. The collider is working perfectly. Look at that. Thank you, Ursina Engine. And we've got a very Minecrafty looking setup, even if a little bit basic. There you go. Right, our frame rate's still fantastic. So what you can then do is play with the seeds to get different terrains. Let's just have a look at that. And octaves I can now explain. So traditionally you would have 8 passes over your noise function, hence octave, and each time you'd have a different amplitude and a different frequency to play with, so that you can create very realistic terrains. I'm not very familiar with this Perlin Noise module actually, so I don't know how to properly set the octaves, although if we go back, we'll go back to our 2021 seed. If I now apply, let's just remind ourselves what it looks like. And in fact, let's be a bit braver and go up 6 meters. Frequency will increase a little bit. Just see what we get. Hopefully I won't glitch through the terrain either. Okay, so it looks like this, more like a plateau, like that. Now let's add an octave, or 3. It's got 4 octaves in total. See what that does to our terrain. It should be more like bumpy. There we go. So that's what octaves are doing. It's kind of introducing more variety. So you might have more areas that are flat, and then we've even actually got a gap in our terrain as well. We've got caves. That counts as caves, right? I can put that in the title. Get more subscribers. Right. Lovely. Okay. I'm just going to pause the recording so I can decide what to do next, so I can keep this short. Okay, so for you, no time passed. I just took a minute or so just to think about what to do next. So what I think we're going to do is make things look a little nicer in terms of our first-person controller. So back to my prepared code. I'm saying the cursor is visible. This is how to set the gravity and the speed. So I'm just going to copy this code. Actually, subject cursor visible equals false. It's probably better, isn't it, for me and for you if I actually type that out. And we'll do that when we create our subject. So subject cursor visible equals false. So I don't like that little crosshair in the middle. And yeah, let's just turn down the gravity. Gravity equals 0.5. And we want to have less octaves. Maybe just 2. Let's just have a look at that, see if our cursor has now disappeared. Oh, and another thing I'm going to try. Oh no, what I can't try now is clicking on the button at the top, the exit button, because our mouse has disappeared if you've got the first person controller. You know what? This is a really nice training terrain. This is really nice. Right. So what we've got to do next is think about, I'm going to stay in the game to explain this, but what we've essentially created is, maybe Minecraft is called a chunk, I'm going to call it a subset of my terrain. And one problem is, if we make a giant terrain and then add a collider to it, it's made of loads and loads of blocks and therefore loads of vertices or corners and triangles, it's going to be very, very slow. So what we kind of want to do is build up the terrain out of blocks, maybe around this size, or maybe if you imagine a single strip, a single line, which is easier to do in terms of the iteration, the loop, we can build it up bit by bit. Also, what we could do is maybe we could just have a tiny area below our feet that has a collider on and just kind of follows us around and just matches the Perlin Noise height, and just makes like a shell, a hard shell underneath our feet. And then the rest of what we're looking at, imagine hundreds of thousands of vertices and things, don't have a collider on. They're just a model and textures, which is very fast for the computer to process. So that's what I've done in the code that I've prepared. I've essentially created two terrains. One terrain which I call a ghost terrain, and that's what you see, but you can't actually feel. So it's insubstantial. It doesn't have a collider on. And then I've made another terrain which is just tiny. I think I've made it like 3x3 blocks, and then it just references the Perlin noise data, so it understands what height to make those 6x6 grids, and it just adds a little collider to that tiny area. So that's the only area that's having to compute the physics, and that's the secret to making things very fast. Okay, so final explanation then. We need to create like a list of blocks that will make up one subset of the terrain. And then each subset, I'll have to have a list of subsets which are a combined model of those blocks. I guess I can call them ghost blocks. And then finally, the whole ghost terrain will be a combination of all of the subsets. So it combines again all of the like the mesh of each subset. And then we don't want to create them straight away. We want to, and let me show you via the other prepared code. What have I done here? I've said terrain width is 50 here, so that'd be fairly quick. And just while I remember, if you want to say full screen, window.fullscreen equals true, you would put. And if you don't want to see the splash screen, you can say, actually, by default, it's going to be false. So let's have a look. So there you see each strip is a subset of our terrain. When that happens, when one strip has been created, it fuses together, and then when they're all created, you may have seen that jolt at the end, when they're all created, the whole thing, so all the subsets, a list of subsets together is combined, so it's as fast as possible. Okay, and I've also got some fog on here, haven't I? So let's turn on a little fog. So scene fog density and scene fog color. And we'll do it underneath the window. Scene fog color equals color red, green, blue. And we'll go for, oh, should we have like a red fog? That'd be weird. Quite bright. I've never done a red fog. And then scene fog density equals 0.4. So that's quite dense. Denser than my my prepared stuff. And I'm just thinking whether to stop the video around here before going to the more complicated stuff. Oh, wow. That was really creepy and really cool. Okay, so that's a lot too thick. Let's just dial that down a little bit. Oh, maybe that's what I meant. 0.04. Before we hit 50 minutes. Yeah. Doesn't work with green really because they're like the opposite end of the color scale. But we've got, you can make large terrains with this, and this is a really easy way to kind of get going with Minecraft. So I think with the next video, we'll do that system of building up a massive terrain with subsets and things. And then in following videos, we'll get the building and destroying block system working, and then we'll play around with mobs and biomes and maybe do some other interesting things with the terrain. If you've got any requests, let me know. Thank you very much for watching. I'll see you next time. Goodbye.